Alright. So the initial plan, I have to adjust my sort of headphones here. My ears are killing me. So we talked about variables and how they relate to registers. We're going to delete this. Registers with a purpose. We're going to relegate this to sort of something that we'll talk about later, because there's been a whole lot of theory, a whole lot of stuff that we've discussed and gone over. And I want to try to make an attempt to solidify this to some extent. How can we do that? We can do that by first emptying the recycle bin. Then we can refresh the desktop. So the way that we're going to do this is we are going to NOP some assembly instructions. This is sort of the easiest way. It's the easiest way, but it's also a dangerous way. But we're going to NOP, or what they call NOP, NOP, some assembly instructions so that the game essentially skips over those instructions, or that it won't even skip over, but as the game progresses through its internal state, we will have NOPed certain instructions so that it will do nothing when it encounters them. And the specific instructions that we will NOP will be decreasing the karma value in the character creation screen. So that's sort of the short-term thesis. So let's just type in NOP, hit enter, see what Wikipedia has to say. Computer science, a NOP, or NOP, short for no operation, is an assembly language instruction, sequence of computer language statements, or computer protocol command that effectively does nothing. I'm sure there's a whole lot of mothers and fathers out there that say my son or my daughter is a NOP, but I'm not going to chime in on that at all. But whatever the case may be, what does this mean? This means that we can find a routine in this game using cheat engine, or let's be slightly more correct about that. We can find a value in this game, and then we can find out the actual assembly instruction that modifies that value, and then we can essentially replace that assembly instruction with a bunch of NOP codes, so that whenever the game tries to modify the value that we're interested in, it essentially or not even essentially, but it encounters NOP codes, it executes, it does nothing. So it does not modify the value, it just NOPs for however many steps it takes, and then that's it. And then it continues execution. So the game is none the wiser. Now, how is this even possible? It's incredibly technical, and I really want to push towards this, and I'm not going to go into crazy detail. I mean, I want to go into crazy detail, but I really want to get to it so that at least one of the series is sort of actively involved in code injection and things like that. But at some future date, I do want to go back, whether it's in this informal series, the more formal series, and explain from a developer standpoint, you know, how is the developer writing code so that these things are operated on by routines and assembly instructions and things like that? And then what does it mean when we actually go back in, or not go back in, but what does it mean when we actually go in with cheat engine and then change or NOP certain instructions? That is something that I find incredibly fascinating. I think that, again, if you made it this far, then it's something that you're interested in as well. But for the informal series, I really just want to get to a point to where we can sort of start messing around with some of this stuff. And if we have to go back at a later date, say, well, we sort of left this out, and then here's what we meant, or here's what we left out, then we will certainly do that. But for the time being, let's attach the game. or attach cheat engine to the game. So we're going to do the same thing that we've done a million times. And frankly, once you get comfortable with this sort of stuff, it just even the basics like knopping instructions becomes pretty simple stuff. You can still get yourself in deep shit if you go around and you just randomly nop instructions and you have no idea whether you're obliterating, the instruction that you think you're obliterating, then you'll crash the game, hands down, no questions asked. Um, Maybe we'll prove that, but I highly doubt it. If you start messing around with this stuff, you'll prove that point yourself because you'll just be like, well, hey, I found an instruction. It's operating on my health address. I'm going to nop it. And then, you hit end turn or you run a frame or something like that in the game, and then immediately it crashes and you're like, what the fuck? Well, again, you can't. When you're starting to get, not even starting, but when you're getting down to this level, you have to really think about what you're doing before you do it. And if your game crashes immediately, and you have to also take this stuff in discrete steps. So, am I going to write 100 lines of assembly code in a script and then execute the script? And then if the game crashes, I'm going to go back and I'm going to debug all 100 lines of that script? That's completely not what you're going to do. You're going to probably write, a dozen lines and then, go back to cheat or like close the script, make sure the syntax and parser and everything since it's good to go. You'll enable a script, disable the script, enable it, disable it. Probably do that, or at least I do it about 6 times, and then I'll run the game for a couple frames, couple turns, whatever. Maybe even close the game down, restart it, re-enable a script, and just sort of check that all the logic is making sense. And there's using the memory viewer. There's some sort of there's a neat trick that you can use to see, which we're about to see a little bit of, um, about whether you're overwriting opcodes that you shouldn't, and whether you're restoring values that you should. And again, we'll see that in just a second here. So let's do exactly what we've done in pretty much every video up to this point. So we're going to do 31. Spend some points. 27. Spend one more point just to be sure. Great. It's almost always the first one I see, it seems. So we'll just take the first one. We have 100. That's great. So we don't need the second one. So what are we going to do? We are going to find out what writes to this address. So what exactly does it mean conceptually when you right click and say find out what accesses or writes to this address? When you right click and you say find out what writes to this address, what you are essentially telling Cheat Engine is, we're going to even type it out to be super clear about it. Find out what writes to this address. What does that mean? It means whenever any instruction changes the value of the value that we selected in Cheat Engine, give me the location, the memory location of that instruction. So you can sort of see that if you read this sort of from right to left instead of from left to right, that you have a memory location, or you have an instruction that has some memory location that's operating on some value that we selected in Cheat Engine, and we want to know what instruction changes the value of the value that we selected in Cheat Engine. So it's kind of a, the left side, the far left side over here equals the far left side over here. Or I'm sorry, the far right side over here to some extent. But that's sort of it in a nutshell. When you select that option, it's basically what you're telling Cheat Engine is, I want to know, show me any assembly instruction that changes the value of this address. Period. So what good is that really doing us? What good that's doing us is that no matter what language, I don't want to say no matter what language, but well, yeah, I'm gonna say that no matter what language a game is written in, whether it's managed code or not, then it's always going to be reduced to some extent to sort of opcodes and assembly and things like that. And Cheat Engine can always drill down and figure that stuff out. So it's able to figure out in assembly language or in some pseudo assembly language what is what is the instruction that is changing the value of this address. So when you right click on it and you say find out what writes to this address, it's going to say, hey, you know what, in order to dig and drill down here a little deeper and give you the information that you want to know, I need to attach a debugger, because this is debug functionality. Are you sure you want to continue? Sure. And then when you go back here, bring this back up, and if we fire an event in the game that actually changes the value of 0E1D44D0, Cheat Engine is going to trap or break on that instruction, or on that instruction, and it's going to populate this table over here. You can pull this over to the right, this first column a little bit. See that it says count, then you have instruction, and then there'll be some other stuff over here. But Cheat Engine is going to break, is sort of a technical way of putting it, on that, or break that instruction, and it's going to record some register state information about, what was the state of the processor when this instruction was executed, and it's going to show you all kinds of memory locations similar to the address that we have right here, and it's going to say, or it's going to return to you, here's the instruction that changed this value. So let's make sure we have enough time to sort of get into this a little bit. We got a little time, so let's fire an event. We talked about events, and we went over this a little bit in a previous video, but we'll touch on it again here real quick. Why isn't nothing in here right now? Because nothing has written to this value. Nothing has actually changed this value. Because when we right clicked on it, we went to show what, or find out what writes to this address. If we went to find out what, let's just do that. Find out what accesses this address. If we do that, do we get any hits? I don't know, maybe there's some clobbering going on. Say find out what access. There is not. There is a subtle difference between the two, and that's something that we'll talk about. But for now, we're just going to use the find out what writes to this address. It makes it a lot simpler, and for our purposes, it removes spurious results that we're not super interested in. So in order to populate this window at all, we have to actually change the value that we found in the game. What's the value that we found in the game? It is karma during character creation. So how are we going to change the value? Are we going to do it through Cheat Engine? We're certainly not going to do that. That probably wouldn't even show up. We're just going to use the mechanics and the events that the game provides us. Bam, or bam. There you go, 87. There's an event. What's the count? The count is 1. So let's click it again. The count is 2. It's reduce. There you go. You can see that reducing it and increasing it are apparently different routines or operations, as the case may be, according to the game. We're not going to focus on reducing it. We're only going to focus on increasing it for now. And so we have available karma 24. We found the value for the karma using our, the same methodology that we did before. We changed it to 100. Now we increased it 9 times. We decreased it 2 times. And we can see that there is some instruction, some assembly instruction in memory in some location, which is giving us right here. And there's some array of bytes, and we'll talk about that way in the future, or maybe not way, but certainly in the future. There's some address in memory that contains a bit pattern that translates to the opcode and move, and then some series of parameters for that opcode. So how are we going to use that in conjunction with NOP to our advantage? We're going to show that in the next video.